In this video, we're going to determine the maximum and minimum values of quadratic functions. It says a farmer is building a fence to enclose a rectangular area against an existing wall, shown in the figure below. Three of the sides will require fencing, and the fourth wall already exists. If the farmer has 164 feet of fencing, what is the largest area the farmer can enclose? First of all, if they say maximum or minimum, and we're talking quadratics, the vertex is always the maximum or the minimum. So we're going to use negative b. So to find the vertex, we always do negative b over 2a, comma, f of negative b over 2a. So to start this, though, we need to write out what this region is. So we have this wall, it's already being used, that's not part of the perimeter. We're going to call this, let's call this W the width, and this the length. So my perimeter is going to equal 2W's plus L. And my area, if I want to find the area, would be the width times the length. Now they already give us the perimeter is 164. So I can write that 164 is equal to 2W plus L. And I'm trying to figure out the largest area the farmer can enclose. So to figure that out, I'm actually going to take this perimeter equation, plug it into the area equation. And to do that, I'm going to solve for L. So let's subtract 2W over, and I would have 164 minus 2W is equal to L. Let's take 164 minus 2W, plug it in for L here, and we get the area is equal to W times 164 minus 2W, which means the area is equal to, if I distribute the W, I get 164W minus 2W squared. So this would be A is equal to negative 2W squared plus 164W. Now to start finding this vertex, which is the maximum and minimum, we need to start by saying that A in this situation, right, little a would be negative 2, and B is equal to 164. So when I go to find negative B over 2A, the x value, right, this piece right here, I end up with negative 164 over 2 times negative 2. So if I do that, I get negative 164 divided by negative 4, which is 41. Oh, but I shouldn't have said x there. We're using W for our variable. So W is equal to negative B over 2A. So that tells me the width of each of these is 41. Now once I have the width, I can find the length from this equation here. So if my width is 41, then I can say that the length is equal to, use this equation, 164 minus 2 times 41. So my length is going to equal 164 minus 82, which is 82. So now I know my width and my length. That means I can find my area because it's length times width. So I'd have 82 times 41. So if I do 82 times 41, I get 3,362. And 3,362 should be the area of that rectangle or that fenced-in region. It said, what is the largest area? Okay, so that would be the largest area right there, 3,362. We got 41 for the width and 82 for the length. Let's do a second example. In this example, it says determine the maximum and minimum values of the quadratic function. It says a sales team estimates that the number of new phones that they will sell is a function of the price that they set. They estimate that if they set the price at X dollars, they will sell f of x equals 1720 minus 5x phones. Therefore, the company's revenue is X times 1720 minus 5x. Find the price x, which will maximize the company's revenue. So they give you this equation for the company's revenue. So we can say that the company's revenue is equal to x times 1720 minus 5x. Now again, maximum, minimum, we're looking for the vertex. So the vertex is going to be negative b over 2a, comma, f of negative b over 2a. So we can start by saying that equation is 1720x minus 5x squared, which I can then write as negative 5x squared plus 1720x. So my a value there is negative 5, and my b value is 1720. So to find this price, which is what they want us to find, x, we can say that x is going to equal negative b over 2 times a, which would be negative 1720 over 2 times negative 5. So I end up with x is equal to negative 1720 all over negative 10, which would be 172. So find the price x, which will maximize the company's revenue. They should set their price at $172. And that's how you determine the maximum and minimum values of quadratic functions.